We are starting a new unit today on circles and the properties of circles. I opted to do this unit over the quadrilaterals unit because I feel like it's a little bit easier, and as a result will fit better into our distance learning plan here. So the first thing we need to do is review some vocabulary that should already be in place from earlier in this year. First word there that we're going to define is going to be the word circle. A circle is a locus, remember that's a fancy word for set, of coplanar points which are equidistant from a single point. That single point is called the center. Remember that equidistance means equal distance. Okay, so down here we've got an example of a circle. This is circle C. Okay, as geometric, we name circles based on the center. So that picture there shows circle C. The next word we need to review is the word radius. Remember, the plural of the word radius is the word radii. Okay, it's not radiuses, it's radii. It is a line segment which connects the center of the circle to any point on the circle. So for instance, AB here, why am I writing AB? CB here is a radius, as would be CA or CD, basically so that one endpoint of that line segment lies on the center and the other lies on the circle. Could be any line segment connecting the center to a point. And the length of that line segment we represent with a lowercase r. Again, we should already know this information. It should not be new. Okay? Grab a screenshot if you want one. We're going to slide down a little bit to get the rest of this vocabulary in from this picture. So grab one if you want one so we can move on. Okay, so in addition, we've got two other words we need to discuss here. Make this a little bit smaller so that everything I want fits on the screen. There we go. First word is the word chord, which we have introduced, but we have not done anything with. Remember, that is a line segment whose endpoints lie on a circle. So for instance, line segment AB would be a chord. Okay. So would line segment DB. That is also a chord. Okay. Even line segment AD would be considered a chord. Okay, those are chords. Now, from there, oops, don't want stickers. The next thing we need to discuss is this idea, or review, is this idea of an idea, let me try that again. This idea of a diameter. A diameter is a specific type of chord which passes through the center. Okay, so for here, we've got, we do have a chord that passes through the center, AD. Okay, and the length of that line segment is the diameter of the circle, which we represent with little d. Remember that diameter is twice the radius. Okay, so that's all the information we had in place from before. Now we're going to take it further. We're going to discuss a lot more about circles than we have previously. So anybody have any questions before we continue? You might want to grab another screenshot. Any questions? Okay, so we're going to move on into discussing new vocabulary, and we will start with this idea of a central angle. And this is something that the kids get these two types of angles in circles confused every year, every time I teach this. So please, please, please pay close attention to this new vocabulary. A central angle is an angle whose vertex lies at the center of the circle and whose sides are radii. Okay? So in that picture, we have angle ACB. That is a central angle. Notice the vertex C lies at the center of the circle, and the sides CA and CB are radii. Now this brings up another important term that goes with circles, the idea of an arc. An arc is a portion of a circle between two designated points on the circle. Okay? And there's notation for this. If you can't tell, there's a little like curved line segment over AB here. In the figure on the left, AB is the arc that is what we call it is intercepted by central angle ACB. Here's the arc right here. That is arc AB. Okay, between A and B. Now, we have to be a little bit careful here, though, because in theory, there are actually two different arcs being intercepted by those points. We have the small arc and the big arc. So the small arc is known as the minor arc, and that's always the one that is less than half of the circle. And then the big arc, we actually have to use 3 letters to name the endpoints and 1 point in between. So if you notice, with the blue highlighter there, I just showed it. Okay, I'll do it one more time here. This is our major arc, A, D, B. Okay? Now, arcs have a degree measure, just like angles, exactly the same type of degree. Okay? They're measured in degrees, just like angles. Okay? And a full circular arc, we should already know, measures 360 degrees. You guys have all heard us say before, you've all heard it before, there are 360 degrees in a circle. That's not referring to angle measure, that's referring to arc measure. Okay? Grab your screenshot if you want one. We're going to scroll down a little bit. Okay. Let's shrink it just a little bit more here. Okay. The measure of an arc intercepted by a central angle is equal in measure to the measure of the central angle. So here, let's say that this angle here is 70 degrees. Okay, let's say the measure of angle ACB is 70 degrees. So if the measure of angle ACB is 70 degrees, then the measure of minor arc AB is 70 degrees. Okay? The arc that's intercepted by those 2 points, the minor arc and the central angle, have the same measure, always. The central angle is always equal to the intercepted arc. All right, so grab a screenshot of that. We're going to scroll down and do some examples of what I'm going to expect you to do on your assignment today. And then we'll look at a couple problems that will be harder than the ones that are going to be on your assignment today. So hopefully everybody's grabbed their screenshot. Here we go. Okay, this should be pretty straightforward here, okay? We need to find the measure of this arc right there. Well, what we just stated is that the angle is equal to the arc. So since the angle is 123 degrees, the arc will have the same measure. So our answer here would be that question mark, or if it were a variable, that variable is equal to 123 degrees. Okay? Real simple, real straightforward stuff. Okay? Central angle is equal to the arc. Grab a screenshot if you want one. Okay, so here's another one. This one's a little bit harder, not a lot harder. No, on today's assignment, there will not be any explaining. It's a new website similar to ones we've used before, but you've probably never used it before unless you're in Algebra 2 right now. Okay, so find the measure of angle 1. Okay, well, measure of angle 1. Angle 1 is intercepting this arc. Now, we don't know that arc, but we do know that the rest of the circle is 280 degrees. Okay, so here's what we know. Okay, the measure of angle 1 is equal to x degrees because it's a central angle. Okay, we also know that 280 degrees plus x degrees has to equal 360 degrees because together they make one full circle. So we're going to solve that equation for x by subtracting 280 from each side of the equation. Whoa, I don't know what happened there. Good Lord. And we get that x is 80 degrees. So we would say the measure of angle 1 is equal to 80 degrees. Grab a screenshot if you need one. We have one more example to do before we discuss the other type of angles. All right. So this is a problem that is harder to do than the ones I'm going to ask you to do today. I'm not going to say we won't have problems similar to this in the future. So that's part of the reason why we're going to do it. So if we look at this problem, it's asking us to solve for the value of x. Now, we do have enough information to do that, but it is not readily obvious what exactly we should do. The only guiding principle we have here is that we have everything we need to figure out x in terms of the x values adding up to be a full circle. If you notice, they've marked these two central angles as being the same. That means that their arcs are also the same. So over here, this arc is also negative 27x minus 3. Didn't mean to zoom in there. Okay. So we have those three measurements. Those three measurements together, negative 27x minus 3 plus negative 27x minus 3 plus negative 37x plus 2 have to add up to 360 degrees. So we're going to go in here and we are going to add our like terms. So we've got 3 x terms to add together. We're going to add those together. Negative 27 plus negative 27 plus negative 37 is negative 91x. And we're going to add our numbers together. Negative 3, positive 2. That would be a total of negative 4. Now it is a two-step equation, so we're going to add 4 to each side. Which gives us negative 91x equals 364. Divide by negative 91. And we get x equals negative 4. Now, don't freak out because x is negative. That is not necessarily a problem. That's only a problem if when we plug it back in, we are getting a negative angle value, a negative arc value, which we're not. When we plug negative 4 back in, those are all positive angles, so we're good. We're fine. Okay? So the value of x is x equals negative 4. So there's our 3 examples of central angle problems. Remember that the central angle is always equal to the intercepted arc. Any questions before we move forward? Grab a screenshot if you need one. Okay. So next we need to discuss one more type of angle, and that is an inscribed angle. An inscribed angle is an angle whose vertex lies on the circle and whose sides are chords. So in this picture, angle BAD is an inscribed angle. Now, inscribed angles, they have a different property than central angles, and this is where the confusion usually arises for geometry students. They get central angles and inscribed angles confused. Central angles are equal to the intercepted arc, and inscribed angles are half of the intercepted arc. So the arc intercepted by this inscribed angle has twice the measure of the inscribed angle, which means the measure of arc BD is equal to 2 times the measure of angle BAD. Okay, either one of those equations, they say the same thing, okay? So if this angle here, let's say this is 40 degrees, then this arc would be 80 degrees. Okay, if this angle is 40 degrees, that means this arc is twice that, or 80 degrees. Okay? And if we know the angle, or the arc, then the angle is half of the arc. The arc is twice the angle is half the arc. So we're going to do a couple examples with inscribed angles as well, and then we will go over how to get to today's homework assignment. Okay? Grab a screenshot if you want one. We're going to move down into the examples in about 10 seconds. Okay. So here is a pretty straightforward problem. It says find the measure of the indicated angle. Well, the measure, that is not the pen tool, the measure of angle CAB, which is an inscribed angle, is half the measure of the intercepted arc BC. So the measure of angle CAB is half of 80 degrees, which means the measure of angle CAB is 40 degrees. Okay, straightforward. And again, as long as we can tell the difference between central angles and inscribed angles, this should be very, very easy. Okay. So we're going to take it up about a half step in difficulty. Grab a screenshot if you want one. We're going to move to another example. Okay, here this one says find the measure of the indicated arc, and it's asking us to find the measure of arc CD. Okay. Now this one's a little bit trickier. In there we have a triangle BCD, and in any triangle the angles add up to 180 degrees. So you can see that we can actually embed other stuff that from previous lessons in the class into these problems to make them more difficult. Okay, so in that there we've got angle B, the measure of angle B plus the measure of angle C plus the measure of angle D. That's 180 degrees because every triangle adds up to 180 degrees. So we plug in what we know. We don't know angle B. We know angle C is 70 degrees. And we know angle D is 49 degrees to get 180. And we solve. So we add like terms. Then we subtract 119 from each side. And we get that the measure of angle B, which is our inscribed angle, is 61 degrees. Now, the measure of arc CD is twice the measure of angle B. So that'd be 2 times 61, or 122 degrees. Done. Again, grab a screenshot. I think there's one more example. I don't honestly remember. We're going to look. Okay, so grab a screenshot if you want it. We got one more we're going to go over. Again, remember that an inscribed angle is half of the intercepted arc. A central angle is equal to the intercepted arc. Okay. Last example. Okay, again, this is going to be harder than anything I'm going to ask you to do on today's assignment. I won't guarantee it won't come up later. So here we have an inscribed angle, which is 31x plus 3, intercepting a major arc of 192 degrees. Well, whether that arc is a major arc or a minor arc, it doesn't change the property, okay? The measure of angle FGE is half the measure of the intercepted arc, which would be FE. So we plug in what we know here. The angle is 31x plus 3. The arc is 192 degrees. So we go ahead and we do 192 times 1/2. So it gives us 31x plus 3 equals 96. And then it's just a two-step equation. So we're just going to solve it like we always do. Subtract 3 from each side. Everybody has proven over and over again that they're capable of solving these equations. Oops, that'd be 93, not 39. And then we divide by 31. And that gives us our value of x as being 3. Okay, any questions? I'm going to stop the recording.